So in this video, I'm going to go over the practice problems. We're going to go through all of them. I will separate up into chapters, but we are literally going to go through all the questions. I have obviously looked at them, but I have not programmed them or really thought about programming them in at least a year. And some of them I've never programmed before. So I'm going to talk through my general raw way of solving things. Just as a note, when you do your midterm exam, you will be using MATLAB Online. Which means you can put whatever files you want on MATLAB Online. So I encourage you guys to create what you might consider a cheat sheet. Just create a text file that just has everything that you want to remember in it. Do not just copy and paste everything in there. That's not going to help you. Go through and meaningfully look at, okay, what are some of the things that I need to remember for week 1 through 7? So thinking about variables and arrays from week 1 and week 3. Doing math in MATLAB, that flow sheet that I went over in the notes from weeks 1 and then week 4. Functions, how to write functions. You're going to be writing some functions for your homework or for your exam. You're going to be writing some script files for your exam. Input, output, fprintf, disp, read matrix, write matrix, all that fun stuff. Branching, if and switch, and then loops, for and while. So put those notes in there in a text file that you can easily reference. You can have other things. You could technically have all of your homework uploaded to MATLAB Online, totally fine. Just keep in mind, you're only going to have 2 hours to do this exam, and there's 6 questions. So you don't have all the time in the world to go through all of your files. Okay, so collect your files, nicely put them together, have a cheat sheet, and then maybe some other backup files. Okay, so problem number one. Over here, it says write a function file, L parabola AH. Okay, write a function file. Start with the word function, and then L parabola. Oh my gosh, equal sign AH. Don't think too much about it. Just copy it down. Every function has an end. Okay, save it. Your functions need to be saved the same name. So if it's called a parabola, your file is named parabola. That takes in values for A and H. You can put comments in here. You don't need to. Maybe you type some comments as notes. So A, H, these are positive integers. You will also have the document with you, so you will have the questions printed out. So maybe you just go over the document and you're like, okay, they're positive integers. Okay, if it says positive integers, you don't need to check for that. It says assume they're positive integers. Calculate the arc length of a segment of parabola given by the following equation. Oh, never mind. Don't listen to me. Here, your function must perform the following. My bad. So pay attention to the following. So here I know I need to do this calculation. So I can type it down right away. L equals square root A squared plus 4 times H squared. Keep in mind you will need to plan out your equation. So if I look at this equation here, the 2 and the H down here are going to need parentheses. This is the square root function. This would be the log function. Let's see, this is a square root. It's a fairly basic function looking at it, but just make sure you keep in mind order of operations. So square root of A, you can also break it up into smaller pieces, but hopefully you're at the point in your programming where you're more comfortable typing it all at one time. Log of 2 times H over A. I don't need to put the 2H in parentheses there. I can, but I don't need it. Plus square root of 2 times H over A squared plus 1. Close that parentheses, and I think we're good. Okay, so I need to do that equation. If A and H are not positive integers, so note keyword if, that means I need a branching statement. Your functions must assign L with NaN and display an error. Display, note it doesn't tell me how to display it, so I can use disp or fprintf. And in general, we're not going to tell you which one to use. Same thing for the branching. It doesn't say use an if statement or use a switch statement. It's you're going to choose which one you want to use. One is probably a better choice than the other, but you get to choose. Here's another thing. If they are valid, then L is assigned using the equation, and I display once again disp and fprintf or fprintf with the following format. Okay, so I'm going to use if because I can't use switch unless I'm comparing one variable with equality with multiple things. I'm not. I'm just checking to see if a is greater than 0 and h is greater than 0. And then do my calculation and display my results. Else, L is NaN, and then display some else. Display something else. Oh my gosh, I can type. Okay, so now we go ahead and display things. For the else situation, when L is NaN, it's literally just one line. So I'm going to use disp, one line of text, error, invalid entry. Don't worry too much about spelling everything correctly. Like if you don't name your function parabola, it's annoying for me, but not the end of the world, okay? You will still get the points. If you misspell the word invalid, totally fine. You will still get the points. Okay, so don't worry about spelling too much, but please try and make sure your functions and files are named correctly. Okay, but once again, if that's your concern, it'll be okay. Okay, so now my else, or my if it's valid. I need to display this given A. So note, I'm going to type given A equals, and then I'm inserting some data. Insert some data, so I need a percent sign. Inserting some data here, need a percent sign. Insert some data here, need a percent sign. And I prefer fprintf if I'm combining text and data. That's just my preference. If you want to use display or disp, totally fine. But anytime I'm combining text and data, I prefer to use fprintf. Okay, so I need those 3 percent signs. So fprintf given a percent. It looks like there's 0 digits past decimal point, so I'm going to say 0.0f, and h equals 0.0f. You can also use %d or %i, totally fine. The arc length is equal or equals, once again, if you don't spell everything correctly, it's not the end of the world, 0.2f. New line. Don't forget your new line. Okay, so the first one is from variable a, the second one is from variable h, and the third one is from L. Okay. So I will save my function. I have typed everything. Now I need to actually call my function. I need to try to test it, which means I have 2 branching things in here. So I need at least to call it twice. One with a valid A value, a valid H value, and then one without those. So if I do L equals parabola 4, 6, which is the example, I can check to make sure my code is correct. So given A equals 4, h equals 6, the length is 15.7. Note, I don't have the period, so I go add the period. I put the semicolon at the end, and there we go. Okay, but that only tests this first branch. That only tests my first branch. So I need to go ahead and use some values that are invalid. So I'll do -2 and 6. Okay, invalid, and then I'll do 4 and -6. Invalid, and then I will test both of them as invalid. There we go, invalid. Okay, so note, we don't always give you all the tests that you'll need. We'll give you at least 1, maybe 2, maybe 3 if we're feeling generous. But we're not going to give you all of the test cases. Okay, so just keep that in mind. Okay, so there's problem number 1. It's saved in my files. Bam. Okay, problem number 2. I'm gonna have to talk faster. Problem 2. Write a function file. Once again, function file. Function z error, if it's lowercase z, does not matter, equals, as long as you are consistent, function calculation xy, which takes in inputs xy as 2 vectors of arbitrary lengths. Okay, so vectors means I'm using my dot notation, my dot math, whatever you want to call it, element by element, and calculates the following function, z of xy. Okay, your function must perform the following. We've got the if word there again. If the number of elements are not the same, so number of elements. How do I do that? I can use numal, they're vectors, so I can also use length. The function must assign z with nan and error with true. If the number of elements are the same, assign z and display. Okay, once again, display, fprintf, or display, or disp. Okay, so if, else, end. Okay, so I've got 2 ends. This is end for function. This is end for my if. I have 2 branches. If it's legit, if it's not legit. So if length of x is not equal to the length of y, then what do I do? Z equals NaN, and error equals true. There we go. That's my first branch. I can test it right away. Can I? Will it yell at me? Let me save my file. It might yell at me because Z might not be, can't be. I guess I could do Z equals -1 and error equals false. I can test it. A, B equals function calculation 1 through 6, 1 through 10. Yep, that's legit. Z is NaN, which is my first output, and then B is my error, which is logical 1, which is true. Okay, so now in my other case, if they are the same, the function must assign Z using equation 1.8 or 8.1. Totally typed that wrong. Should be 2.1. We all make mistakes. Hopefully I didn't make any of those on the midterm. But if the number of elements are the same, then I calculate Z. Z equals 0.6 times x cubed times exp negative 0.47 times y plus 1.5 times y squared times exp negative 0.6 times x. Okay, note, once again, planning it out, E is the exp function. Okay, make sure you guys remember that. And I need to use dot notation. So I type my equation exactly the way I did in week 1, and then I go through and I add a dot in front of all of the asterisks, in front of all the carets, and in front of all the division signs, which I don't have any in this equation. I could have typed them as I went along, but I purposely didn't because that way I can go through it all at once. Okay. Okay, so last thing I need to do, display. I'm displaying a table. It doesn't tell me exactly how I need to do that, but since I'm displaying a table, I'm going to use the disp function because I just think it's easier. Okay, so disp function, I'm going to choose use format short G. So I can nicely align things, force it in that format, and then I can display all of my data. Note, well, first I have this text. Note I have this text, so that's going to be one display. And then I have all this data. It's going to be a second display. But first I need to grab all of my text into one single array. So I'm going to create an array with my x values, my y values, and my z values. And note they need to be columns. Okay, so if any point in time you're wondering what in the world x and z are, you can say x equals 1 to 5, y equals 11 to 15, like the example, and then go to your workspace and be like, x and y, these are rows. They have 1 row, 5 columns. So I'm going to need to make sure they are transposed. So my data is going to be x transposed, y transposed, and z transposed. Yep, z will be transposed as well. Okay. Technically, x and y could also be columns, and it should still work, but we're just going to pretend they're always rows, just as what the example shows. So then I print out the words x, print out the word y, print out the word z. I will fix my spacing later. And display data. Okay, so here's that first line, and here's all my second lines. Rest of the lines. Okay, so then I can go ahead and test it. Z E equals function calculation x comma y. Okay, there we go. My data is printed out. I want to go ahead and align this x and y here. Just add a bunch of spaces. See how it works. If you don't have time for that, totally fine. Not that big of a deal. X goes over 2 more times. X is lined up, Y is lined up. There we go. It's printed out. And I can look at my numbers and I can be like, okay, yep, I printed everything out correctly. Okay, so that is question number 2. Okay. Note we've got branching, we've got functions, we've got display, we've got calculations, all that fun stuff. Question number 3, write another function file. Function MMR construct matrices A, M, N. This right here is points. Literally writing this down, that's points. So if that's all you can do, that's fine. Do something. Okay, but if this is where you start, totally fine. Okay, M, N are arbitrary. It doesn't tell me I need to use any if statements. Okay, so literally just assume they are those values. I don't need to test it. Okay, A is an arbitrary scalar. Okay, keep that in mind, scalar, it's 1 by 1. These are integers, so these all are scalar values. Okay, my output is M equals an M by N array. So M is an M by N array. So I'm going to go ahead and create it with zeros. Zeros, M, N. That's how big it is. Okay, M by N. Row 1 is numbers A, 2A, 3A, 4A, etc. So if A is 2, then it's 2, 4, 6, 8. There's a couple ways I can do that. Row 1, all the columns equals A times, I can do this, times this array, 1, 2, N. Yep. And then I'll just make MR equal to -1 for now. Then I can test my function as we go along. So I can say MR equals, construct matrices, and look at my example, 2, 8, 5. Hey, yay! There's M. So no, it's A times 1, A times 2, A times 3, A times 4, A times 5. So N is 5, it's the number of columns, so I just say 1 to 5, and then A times those values. Okay. It is dot operation, so I couldn't put the dot there, but A is a scalar, so technically it works without the dot. My second row is numbers N raised to the A, N minus 1 raised to the A. So note in these, the basis here is this array. It's N -1 with a spacing all the way down to 1. Just going the other way. And then all of those numbers are raised to A, right? My power is all the same. A. So there's that one. Once again, I can go ahead down here, test my function. 25, compare it. Okay, I got that one. Then we go on to row 3. So row 3, all the columns in row 3 are the elements of row 2 times row 1. So row 2 is this syntax. Row 1 is this syntax. And I'm going to multiply them by each other. So note it's element by element, so I need to go ahead and use the dot notation. So 50, 64, 52, there we go. That one works. Row 4, M4 equals the elements of row 3, which is this notation. Square that. So once again, dot notation. Squared dot divided by row 2, which is this. Row 2 squared. Okay. Test that. 4, 16, that is not what's listed. So let me double check. Elements of row 3 squared divided by row 2 squared. So 3 divided by 2. Row 3 divided by row 2, so 50 over 25 squared should be 4. 64 over 16 squared should be 16. Okay, so there's, sorry about that. So there is something wrong with the solution. I'll fix that. But this makes sense, right? If it doesn't make sense, please let me know. Okay, so then, so 4, 16, 36, so 54 divided by 9 is 6 squared. There we go. Somehow I got 14. Maybe it's supposed to be divided by row 1. Nope, that wasn't it either. Times? Something went wrong. Okay, but row 3 squared divided by row 2 squared. And then row 5. It is not impossible that a mistake is made, but if if you do think there's a mistake, double check it. Okay, do not just say, oh, there's a mistake. Double check it to make sure. Okay, like I just did. We will figure it out eventually. Elements of the absolute difference. So the absolute difference of row 4 minus row 3. Which this is going to be off. 46. So 4 minus row 3. Yep, okay, that makes sense. And then row 6 to row M is all zeros. So that's already true. That's already true. It's all zeros. Okay, then we've got MR. MR is the M array after adding 2 more columns of 1s to the right. So I just do array concatenation. This part here is M. This part here is 1s. How many 1s? It's got how many rows? The same number of rows as M, which is the input variable M, lowercase m. And how many columns? 2. It's always 2. It says adding 2 more columns. So I go ahead and construct that. M placed next to 1s of M by 2. Test it. Oops. Close my brackets. Test it. And there we go. We can see match it with the solution. We already know there's errors, but we can see right there that matches what we should expect. So that's question number 3. Question number 4. Write a function. Okay, note the prevalence of functions. RMVD calls. You can name your variable names whatever you want as long as your function is the same. Okay, just keep that in mind. So you could call it uncorrupt, you could call it U, you could call it R, totally fine, not a problem. Which takes in an array, note any size array, and removes the columns of A that have at least one value of 0.9999. Okay. You must perform the following. Assign uncorrupt with matrix A with the columns removed. So U is going to start out as A and then remove my columns, and assign removed with the indices of the removed columns. So which columns have invalid values. So I can do this with branching. I can do this with loops. I can also do this with indexing. So I don't know. Which way do we want to do first? Let's do a couple ways. Okay, but first U is A, because. So I'm going to loop over the columns. For I equals, I'm not going to do that. RC, size of A. So for I equals 1 to the number of columns. I'm going to say removed equals empty. I'm going to use this to store the columns that are removed. And yeah, I'll say U equals A. Remove from this matrix. Okay. So for I equals 1 to C. So now I'm going to go ahead and look at A here. So let's say A is example 7, 4, 8, 1, 8, 7. There's my invalid value 1, 8, 2, 3, 9. So now I'm going to go ahead and say, okay, let's look at this first column here. So A, no, I'm going to say, oh gosh, what do I call my variable? A, doesn't really matter. I don't know why I'm struggling with this. J, or invalid value equals A. What part of A? The first column of A. So all the rows in column I, because it's going to be 1, then 2, then 3, then 4. A equal to negative 9999, right? Has at least one value with negative 9999. So if I look at this, this is going to be an array of, for this matrix, it's going to be, for column 1, it's going to be 1, 1, or 0, 0, 0. It's going to be 3 values. So if the sum of my invalid values is greater than 1, then I'm going to remove the column. So U, all rows, column I, equals removed. Equals empty. And then R equals R plus I. So whatever R was previously, remove column, store column, removed in vector. Right, yeah. And there we go. So then that's the first column. So then it would go on to the second column. And this would still be 0, 0, 0. And then it would go on to this one, and it would be 0, 1, 0. So that means this would be true. It would remove it and then add to that. And then this one. And there we go. It's one way to do it. So we have an algorithm. We have some sort of value, some sort of way to do it. Now, you don't need to add the comments, but this is what we have. That's the number of rows. If at any point you want to rename, you just rename it. Okay, I already had an R, so I just removed that. So let me look at this example. So there's A. So if I go ahead and call my function, okay, it didn't work. So then I need to go through and figure out how and why. I equals 1 to columns. One of the ways I can do this is I can go ahead and put in a breakpoint there, and I can go ahead and step through. So now if I look at my workspace, I can see all of my variables inside of my function, and I can step through. So for I is 1, invalid value is, yep, should be 0, 0, 0. So if the sum of that, nope, keep going. I is now 2, invalid value is also 0, 0, 0, so that should be invalid. I is 3, invalid value is 1, so the sum of that should, I have an incorrect here. It should be greater than 0 or greater than or equal to 1. There we go. Remove that breakpoint, recall my function. Another thing you could do is you could put a semicolon or remove the semicolon and print things out and see how that goes. You can also use print statements, but here we go. It matches the input. So this is one way to do it. Another way to do it is you technically don't need loops or branches for this. You could do it with just logical indexing. So you could say invalid values equals A equal, don't forget your double equal sign. Okay, so this will give me all of them. So I'm going to go ahead and comment this one out. Gives me all of them. And then I can sum along the columns. So we can say S equals sum along the columns, which A in first dimension. I would need to print that out to figure out which one it is. Okay, so the sum, my bad, not sum A, sum in the invalid values. Yeah, don't yell at me. Okay, and then you can go ahead and say A, all the rows, nope. Yeah, all the rows in these columns are going to be empty. And then U would be one through number of columns, size of A, 2. And then U is going to equal U wherever S. Something along those lines. Let's run this. And then we can talk through it. Position 2 is invalid. Line 16, A, S, 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 S. Our rank indices must be positive integers. They are logical values, are they not? Oh, logical. Yeah. Let me make this logical. Logical just means I'm turning it to true or false. Whoops. This is supposed to be R. My bad. There we go. Logical means I'm turning it to true and false. So the way this works, so let me go ahead and once again go through it. So invalid values. So here now I'm saying, okay, if I look at A, which ones are equal to negative 99, negative 9,999? So it'll give me all of these. Just like I did up here where I summed them, I need to sum them, but I need to sum each column. So this is what summing along the columns does. So if I do sum here, it gives me the sum along the columns. This one says do it along the columns. If you put a 2 in, do it along the rows. We use the sum function in one of the homeworks. I can't remember. Logical turns these ones and zeros into true and false. So if there were 2 values, it would turn 2 to true. And if there's no values, it'd be 0 and 0 is false. So S gives me a logical array that's true wherever there's a column with that value and a false wherever there's not. So now I'm saying A, which part of A? All of the rows in the columns that are true, go ahead and delete them. So this is going to delete all of the columns that have a true indicator. And then I'm saying, okay, U equals A. That's my output. Then I'm saying R equals 1 to the size of A because I want 1 to the columns. So however many columns. Oh, shoot. I should do this up here. Do this up there. The order matters. Our remove columns is 3. Just by happen chance, that was lucky. But I can say 1 is the size of A. Size of A, so R equals 1 to 4. And then I can say which columns do I want to keep? The columns where it's true. So I want the 3. Okay, so this is another way to do it. This one's a little harder for students to comprehend just because it's a different way of thinking. This one makes a little bit more sense because it's a little bit more logical in terms of the way we think about step 1, step 2, step 3. But you can also do this without branching, without loops. We did not tell you how to do it with specific structures. So that means you are free to choose whichever algorithm you want in order to accomplish the task. Yeah, so that one's a little bit more challenging, a little bit more, I don't know, you might call it fun, you might call it more annoying, but it doesn't make you think. Okay, next one, write a function file. Note, a lot of function files. Modify array AN. Okay, this takes in a square array A. So note, square meaning same row, same number of columns of arbitrary size, and n as an integer equal to the required size of the new array B. So B is going to be a new array. Looks like it's a new square array. So B, I'm going to go ahead and create it, zeros of n. Okay, it's a square array. That's what it says. If, note, we've got that keyword if. If says, hey, use branching. If n is greater, or if n is less than m, so there's my first conditional, the function must assign B with A. So n is less than m, which means B is smaller. Must assign B with A, where A is reduced in size from m by n to n by n by deleting rows and columns off the bottom right. So here's A. I delete rows off the bottom and columns off the right. Okay, so here is the extra ones. Okay, so let's go ahead and do that one. So if, I don't actually probably need this, but it's just a note. If, I do need the size of A. M, comma, equals size. Okay. Notice M, can I do that both the same? M and M? Same size? Okay, so if, I could also just get the number of rows. Doesn't matter. So if n is less than m, if n is less than m, then B equals A. And I'm going to delete my, no, I'll say B equals A. I don't need to delete. I can just say it's just this part of A. It's just this part. So it's actually A 1 to n, 1 to n. Yeah, that makes sense. Okay, so that one's done. Once again, you could also add your own algorithm. You could literally delete. You could say b equals a, and then you could say b delete which part? N plus 1 to m. All the rows equals empty. And then b and all the rows and n plus 1 to m equals empty. And this will also do it. Obviously, it's more lines of code, but if that makes more sense to you, that's totally fine. Note, you can only delete rows and columns together. So make sure it would have to be in 2 lines. You can't delete them all at the same time. Okay, so that's option number 1. Option number 2, if. So here's another conditional branching statement. So I have an else if n is greater than m. Then it must assign b with a, where a is increased in size by adding zeros. So now b is bigger, and I'm going to insert a here. So add in zeros. So this, I can say b equals zeros, n. And then I can say b, which part of b? 1 to m equals a. Another way you could do it is you could say b equals new array, a, placed next to zeros, and you would need to figure out, okay, how many zeros do I want to put over here, how many zeros over here, and you can construct it one piece at a time. Okay, so you can use concatenation. I'm gonna comment that out. I don't want to do it that way. I did it this way. Why should I think of a different way? But you can figure it out. Okay, fine, I'll do it. A placed on top of zeros. How many zeros? N plus 1 to m 0. Nope. M plus 1 to n zeros. And I want to put that next to. Do that first. And then I want to put that next to zeros. How many zeros? M zeros. So that's how many rows is m, because m is bigger. Nope, n. N is bigger. N is bigger now. N zeros, and then m plus 1 to n. Hold on. This would be n minus m zeros. Something along those lines. I might need to add a plus 1 in there. Something along those lines. Close out my bracket. Something like that. We can test that later. Okay, and then if m, here's my other instance, else b equals a. There we go. Okay, so I've got my 3 branching, 3 code blocks. There we go. 3 options. If n is less than m, n is greater than m, and if they're the same. Okay, so now we go ahead and test. Once again, I don't have all of my testing options. I just have one case. So I can say b equals modify array. A looks like, I don't know. A is a random array. It's square 10. It's got, let's say 4 rows, 4 columns. So let's say A looks like that. B equals modify array. And we can say A, and let's say we want to make it a 2 by 2. Okay, so that's works as a 2 by 2. Let's say it's a 6 by 6. There we go. That works. Let's say it's a 4 by 4. That works as well. So I can have to test each branch. I don't have to use the example that's exactly given to me. This one is a very simple example. I like to use this just to be like, hey, well, what if A is bigger? And I can go ahead and logic and be like, okay, I'll make it smaller. This one's a lot harder to make smaller. So I've been able to easily just make it smaller with a larger array. Okay, but you can use the rand function. Yeah. Come on. Okay. Question 6. Hey, we're not writing a function file. We're writing a script file called system. So I'm going to go ahead and save it. Wrong one. Save it as system. That solves the following system equations. Note, I have 6 unknowns. 6 equations. So I need A. I need B. And that's it. So unknown 1, 2, 3, 4, 5, 6. You can go ahead and you can type it directly in your code right away. These ones aren't too bad because there's no zeros. But I would literally just go through. The hard thing is making sure they all line up. If there are zeros, it obviously makes it more challenging. But I'm going to go ahead and put my unknowns at the top. A equals -1, -1, 3, 2, 8, 7. Line it up. Once again, just makes my life easier so I can easily see, especially if there's zeros. So -2, 3, -7, -6, 10, -5. Row equation 3, 6. This one's just tedious, but it's important you understand how to set this up. You won't need to solve anything by hand for the exam, but you do need to know how to solve and the principles of solving a system of equations. So thinking about, okay, what are the steps to find the inverse, finding the determinant. Okay, I have a 0 here. In equation 4, 1, 2, I've got a 0 and a 3. This is what happens when I'm trying to teach and solve at the same time. The same one here. So this one's missing an x3. This one's missing an x4. This one's missing an x1. Okay, so keep that in mind. So then equation 5. I think I'm at 5. 1, 2, 3, 4, 5. 7. -5. 10. Then I've got my 0 there. It's a -7. Once again, you will have your questions printed out, so please bring a pencil so you can write on it. It can and will be helpful if you can do that. I forgot my 0. There we go. There's my A matrix, my B vector. It's all the numbers, all these numbers alongside. 91, -15, -36. It has to be a column. So you can do a couple things. You can make it a row vector and transpose it, or you can separate them by semicolons. And then x equals A left divide B. That's it. That's it. Don't get fancy. Just A left divide B. And it says display your results. You could technically use the inverse function. You could find the determinant and divide. What's the inverse? The inverse is 1 over the determinant times A adjoint. There's no function to find adjoint, but you could find the inverse. Or just do A left divide B. It's less typing, less thinking. Move on. Displaying my results. So note there's 6 results, so I will need to extend this. I am combining text and data. I can do this with one fprintf. So before I do that, though, I need to go ahead and create an array for my text. x1. You don't need to necessarily do this. You could type them out one line at a time. I will combine my data into one. It'll be text transpose next to x. X is already a vector. And then I can print it out. So fprintf, that's not true. I want text stacked on top of x. So x transpose. And then I can go ahead and fprintf, and I can say insert some text, I don't know, say with a 3 equals some data, 0.2, we'll make it a width of 4, f, new line, data. Okay, run this. NaN to, okay, so clearly I did this wrong. Data has X1 on top. Why is it typed wrong? Fprintf, what does day look like? Ah, that's why. Stacked on top of. I can do this. There we go. That looks better. Space that out to 5 because I've got that negative in there. I don't need 2 digits past the decimal point, but it tells me to print 2 digits past the decimal point, which is fine. You would not be penalized in this instance, probably. But in general, if it says 2 digits, print out 2 digits. We want to make sure you know how to use fprintf, or you need to know how to make sure you... Actually, what do we take points off? I don't know. I would probably be forgiving. If you did display with this, I would be forgiving, as long as it's more or less in this format, where you have text and then you print out the digit. Yeah, there we go. That's how it looks to print out. Notice data is like this because the relationship with fprintf and printing out tables is transposed. So if I want it printed out like this in columns, my data that I'm printing out needs to be in rows. Fun fact. Okay, question 7. There are 13 of these guys. There are 13 of these. Write a function file. Back to our functions. M equals substance mass vs. Let me fix that. And, okay, what does this function do? It takes in a volume and a substance, single or double quotes. Okay, so that's fun to know, and returns the corresponding mass. Okay, here it says use a branching structure. It does not tell you which kind to use. You can use if or switch. Doesn't matter, but use a branching structure to calculate the mass of the substance as the volume times the density. Okay, so there's no equation in here, but it's volume times density. What is my density? Depends on this table. Okay. Display the mass of the substance in the following format, where X is the volume, Y is the mass, and S is the substance. If the substance is not recognized, assign M with NaN. Okay, so I've got that else conditional in there. Okay, so I need a branching statement to figure out the density. Note I am comparing my substances. If the substance equals water, if it equals air, if it equals oil, if it equals mercury, anytime you're dealing with text, you generally, not always, but generally might think, maybe I'll use a switch statement for this. Switch looks like this. I'm switching on the substance. S is the substance. Double quotes, single quotes, doesn't matter. S is my substance. My cases, compare it to water. My cases, compare it to air. My cases, compare it to oil. My cases, compare it to mercury. Mercury. And then, oh, come on. My otherwise. Okay, so there's my conditions. Okay, so if S equals water, if S equals air, if S equals oil, if S equals mercury, anytime you have that structure, you can use a switch statement, which is generally easier to write than saying if S equals water, if S equals air, else if S equals oil. Okay, but not invalid. So if it's water, then the density equals 1,000. If it's air, the density equals 1. If it's oil, the density equals 800. If it's mercury, the density equals 13,6 something, 13600. Otherwise, where's my otherwise? M equals NaN. Display unrecognized substance. Okay, return. In function early. The reason why I want to do that is because my switch statement only calculates the density. So I need that density calculation down here, where my volume equals, my mass equals my volume times my density. So I only want this done if I have a valid density. Okay, so if I don't, then I want to end my function early. And then I need to display, or fprintf. Note, I'm combining text and data. Here I want to use fprintf. This xxx %f. This is %s. This is %f. It gives me, doesn't tell me how many digits past the decimal point, so I will use whatever makes sense. Note if you look at the examples down here, it's 2 digits, 2 digits, 2 digits, 2 digits, because I can use it as an example. If it doesn't tell you explicitly which ones to use, then just come up with your own. You can do 3, 5, 6, whatever. Just come up with your own. So f print f, percent 4f, m cubed of oil, of my substance, percent s, equals percent my volumes, 2f kilograms. Those aren't volumes, those are masses. Okay, volume, substance, mass. Okay, make sure you print out the right quantities. Okay, so now I'm going to go ahead and test. Once again, you have 1, 2, 3, 4, 5 different branches, so you should test it 5 different times. We only give you 3 options. So test these. Um, 200 kilograms. Test those. But then you also want to make sure. Okay, that one works. You want to make sure it works for all of them. So what if it's water? 0.1 times 1,000 is 10 kilograms. What if it's air? 0.1 equals 0.1. Okay, and then what if it's unknown? Okay, unrecognized substance. Okay, so you want to make sure you test all of them. Use simple problems. You don't really get a calculator, but you can calculate it in here, in MATLAB. Calculate things here. Or you can use easy numbers that are easy to manipulate, easy to work with, easy to figure out. Okay, problem number 8. So we've got some background for this question. The following table shows the price for renting a car at a car rental company. Notice it depends on the type of car we have. Okay, so that matters. Type of car. And I think that's it. Type of car. Yeah. Type of car. Oh, and the number of miles. So 3 miles per day, but mostly the type of vehicle. So write a function file. Function cost equals car rental. Vehicle, days, miles. And once again, your variable names don't really matter as long as your function is named correctly. Takes in the vehicle type as car or truck. Note, double quotes. The days rented and the miles driven. Determine the rental cost in dollars. Your function must do the following. Use a branching structure to calculate the cost of the rental rounded to 2 decimals given the inputs. Display the results. If the vehicle type is not recognized, so notice we've got an otherwise, display the message. Okay, so I'm going to go ahead and start by just doing a branching structure. Depends on the type of vehicle. So if the vehicle equals car, if the vehicle equals truck, once again, that's a switch statement. Switch on vehicle, case, car, case, truck, otherwise. If that's not the case, otherwise the cost, I don't say anything about cost. Cost equals NaN. No, it doesn't say. Display unrecognized vehicle database under construction. I will go fix that. And then there we go. End for my switch, end for my function. Okay, so there's my otherwise. So I've already taken care of this piece. Then I have my cost for the rental. So if I look at this, the cost for the rental depends on the number of free miles. It depends on the miles that the car has been driven. So if miles for a car, if miles is over 100, or if miles is less than 100, or equal to 100, then my cost is daily rate, which is 89 times the number of days. However, if my miles is more than 100, then my cost is 89.99 times the number of days plus the additional miles. So it'd be 100 miles minus 100 times 0.89. So here's my additional miles. So I get 100 free miles, so that is this piece. Then anything above 100 is 89 cents to the mile. There we go. There's that one. And then for the truck, it's similar. My base rate is more. It's 129. My additional miles are $1.39. Save it. Okay, so there's my general piece. I need to go ahead and add in my display. So once again, I'm going to use fprintf for this because I'm adding in text and numbers. So where do I want to put that? Oh, I'll put it here, fprintf. For this many days and this many miles. I'm going to go ahead and print this out as integers. Rental cost equals $, 0.2f, because money is rounded to the 2, so it makes sense. So I've got days, miles, and cost. And I need that printed out for cars and trucks, so I will print it out here. Okay, so I've got 1, 2, 3 cases, so I need to make sure to test my code 3 times. But I've got cases inside of those, so I've got 1, 2, 3, 4, 5 different cases actually. So cost equals car, rental, car, 10 miles, nope, 10 days, 20,000 miles. Okay, so 10 days, 20,000 miles, the rental cost. Okay, I didn't do my calculation correct. Car rental, 10 days. Why is my cost so much higher? For a car, it's this one, 89.99 times 10 days, that's $899. Miles, 2,000 miles, so 1,900 times 0.89 is 1691. Am I understanding this table incorrectly? 1789.9? 1789.9 minus 899.9. 890, so that's how much the mile should be. And that's how much this says the mile should be. It's 2,000 miles. Minus 100 is 1,900 times 0.89. Maybe the table changed? I will look into this. Yeah, I will look into this because this doesn't make any sense to me unless I'm grossly misunderstanding something. Let's look at the other one. Car rental for a truck. 10 days, 20,000 miles. Once again, something is grossly different. And then let's do an invalid. There we go. And again, vehicle unrecognized, database under construction. Let me test my other conditions. So a car for 20 miles. So that makes sense. And a truck for same thing, 20 miles. That makes sense. Times 10 days. Okay, so that makes sense. So I will look into this additional calculation and double check. Maybe there was something incorrect with the solution. I promise I did check the midterm problems. Okay. For these ones, I'd like to program them raw to kind of see how things go, how it might compare in your exam. Question number 9. Write a function file. Function CD equals A, V, S, B, A, B. Whatever VS means, we'll figure it out. Takes in A and B as 2 vectors of the same length. Okay, same length. Important. And returns C as a vector of all the elements of A that are even, and D as a vector of all the elements in B, A and B that are odd. Okay, so C is my even vector, D is my odd vector. Okay, once again, it doesn't tell you how to do this. So if it doesn't say use logical indexing, You can use branching, you can use loops, however you want to do that. However, I'm going to use logical indexing because it's going to save you a lot of time. So C is a new vector of the even elements. Which even elements? The even elements of A. How do I determine whether or not an element is A? I want to grab A, the part where A is even, where A mod A comma 2 equals 0. Help mod, or help remainder. Help rem. I think that's one we use in class. Help rem. M is the remainder after division of A by B. So let's say we have A equals rand I of 10. It's got 3 rows, 4 columns. We'll do, what is this, 10? 1 row, 10 elements. And I say mod rem A comma 2. There we go. Okay, so wherever that's 0, I want to grab those numbers. So I want to grab A, which part of A? The part of A where the remainder is 0. And I want to place it next to B, which part of B? The part of B where the remainder is 0. Yeah, I think I got all my parentheses correct. Yep, place them next to each other. Okay, so let me go ahead and that's A. Let me go ahead and make B. B is also a random vector. So then C, D equals A, V, S, B, A, B. Oh, I gotta save it. Save. VSB. Okay, so if I look at this, it's got the 10, the 8, the 10, the 10, and the 8 from A. And then from B, it's got the 8, the 4, the 2, and the 8. Okay, so now I need the odd. The odd is very similar. Very similar. I'm going to create a new vector. And what do I want to put in it? I want to put A, the part of A. Which part? The part where A is odd. Next to the part of B. Which part of B? The part where B is odd. So this here's my logical indexing, where I'm grabbing A. Which part of A? The part where A is even. Grab A. Which part of A? The part where A is odd. Or where it's not even. There's a couple ways to do this. Okay, so that's saved. There we go. So now I also have the odd pieces of A and B. So it's got the 5, 7, 1, 9, 7. And then it's got the 7, 1, 3, 1, 1, 9 from B. Okay, so that was not a long problem, and it's really 2 lines of code. But if you use loops and if statements, it will make your code a lot longer, which is fine. If that makes sense to you, do that. Just any way we can kind of shave time off is going to make our life easier in terms of typing up our code. Okay, number 10. The letter grade cutoff ratios in a % of a course in terms of the overall score are given in the following table. So once again, we got some background. In a table. I need to go ahead and get that data. Oh, crap. I have that data on my computer. So let me go ahead and grab it. So on to question 10. So we've got the letter grade cutoff ratios in a course are given by the following. So note, I'm probably gonna have some sort of branching or logical or some sort of conditional statement. I need to go ahead and write a script file called grade stat. So I've got my file. Let's go ahead and save that. Grade stat. Oops, forgot the underscore. That's fine. Just go rename it. Grade underscore stat. That does the following. Runs the file scores.p. So I have scores.p in here. I downloaded it. I uploaded it to MATLAB Online. So scores p, I can literally do it by just typing scores. Wee. Run that, and you can see now, oops. Let me do that again. There we go. I've got my scores, my variable, my data in there. So what do I need to do? Determines the average scores in the class using the built-in mean function. Okay, so first of all, this data contains 2 columns. So 2 by 10, 2 by 100. So 2 columns. So the first column is the student ID. Second column is the score. So we've got this table. Column 1, column 2. Okay, so I can go ahead and break that up into pieces. IDs is, what is this array called? Scores. All rows, column 1. And then the grade is scores, all rows, column 2. So if I want to find the average grade, so S average equals mean of G. There we go. I have the average grade. So if I run my code, the average grade is 94, which seems a little high. Oh, this wasn't corrected either. The example, my bad. The average grade is 94. That seems a little high. 2 by 100. So 2 rows. So row 1. That would help if I could read. Let's try this again. There we go. The average is 73.909. That seems a little bit more realistic. Ignore this example. It was clearly not updated properly. Once again, I'm writing these raw off the cuff. I did not check the answers for the examples that were given. I will fix them. But I did check the midterm, okay? So, the mean determines the number of students above the average. Oh, maybe it does. Maybe it is correct. Maybe it is correct. We'll see how it goes. And AAVG equals, using the built-in sum function, determine the number of students above the average. Okay, so number of students above the average. I want to grab the students, which students, or I want to grab the grades, which grades, the grades that are above the average. Okay, so this will give me a logical array. So this, if I execute this gives me essentially all these things. Which ones are above the average? Gives me all the grades that are above the average. I don't want the number, I don't want these grades. I want the number of grades. So if I look at this is the true or false. So I don't want which grades, I want the sum of this array. Okay, so that's the sum. So the number above the average, 49. Hey, it does match. Woohoo! I'm just need to keep reading, which is pretty normal. Determine the number of students within 5% of the average. So n underscore 5 average equals the sum. Well, which grades? I want the grades that are within 5%, which would be, I guess, if it's out of 100, then it would be plus or minus 5. So the grades that are greater than or equal to the S average plus 5, and the grades are less than or equal to the S average minus 5. Once again, I don't want, let's see which grades those are. Working with arrays, double or single ampersand. Okay, so that's empty, which means I did something wrong. The average plus 5, evaluate 78. Okay, so grades greater than or equal to 78. Okay, those are those ones. S average minus 5. I want the ones less than, there we go, less than above and greater than below. There we go. That gives me those ones. So I don't want which grades, I want the sum of those grades, which is 33, which matches. Okay. So there we go. Determines whether students in letter grades E and F only. E and F. There's no E. A. I'm assuming it means A. A and F. I will change that. Okay, so NA is the students, which grades? The grades that are greater than or equal to a 90. Number of F, same structure we've had. grades. Which grades? The ones that are below between a 60 and a 70? That's incorrect. That are below a 60. I will update this table. So here's my otherwise. So score less than 60. So there's my F. So look at those. 9 A's, 11 F's. And then the last one is the IDs of the students. So I want to know which students got A's and which students got F's. So ID of A's would be similar idea. I want to grab the IDs. Which IDs? The IDs where the grades are greater than or equal to 90. I want to grab the IDs. Which IDs? The ones where the grades are less than 60. There we go. Okay, so this is my logical indexing. Okay, this is my logical indexing. Okay. That's question 10. Question 11. In mathematics, the Pell numbers, okay, it's just ignore the name. It's an infinite sequence of integers known since ancient times that comprises the denominators of the closest rational approximates, blah, 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 blah. Each subsequent number, this is the important piece right here. Each subsequent number is the sum of p of n minus 2 and 2p of n minus 1. So begins with 1 and 2. Okay, write a function file. Function p n 5 equals L of n. It takes an integer n greater than 2 and returns p. So if n is not greater than 2, if n is less than 2, then p equals nan, and 5 equals nan. Return. Okay, otherwise, go ahead and calculate the first n numbers of the Pell sequence and the vector n5 as the number of elements in p that are divisible by 5. Okay, so I need an equation. Figure out my Pell numbers. It's 1, 2, and then my next number is p of 1 plus 2 of p of 2, right? And then p of 2 plus 2 p of 3. And then p of 3 plus 2 p of 4. Essentially, it's p of n minus 2 plus 2 p of n minus 1. Yeah. So I just start there. P equals 1, 2. 4, I equals 3. That's my third number. That's the first one I'm gonna put together. I guess I call it little n. N equals 3 all the way to big N. Then I just keep adding on to p. So p equals p plus my next number. P of n minus 2 plus 2 times p of n minus 1. So it goes all the way up to n. I'm going to go ahead and put n5 equal to 0 at the moment so that we can test to see that we calculated the number correctly. So p and n equals Pell of 10. I need to save my function. Save. I did not mean cell. I meant Pell. So no, this will give me an error because it's not greater than 2, but let's do 10. So, 1, 2, 5, 12, 29, 70, 169, 408, 985, 2, 3, 7, 8. Woohoo! Yay, go me! So now I need to go ahead and grab all of the numbers that are divisible by 5. Or the number of numbers that are divisible by 5. So in this one, it would be 5 is divisible by 5, the 70 is divisible by 5, and this one's divisible by 5. So that's why it's 3. So I want to grab the number of elements in P. Which elements in P? Where P divisible by 5 equals 0. Okay, so this will give me double equal sign. So this is giving me the 570 and 985. I don't want that. I want the number of elements. So I just replace it with some. And there we go. It gives me my 3. Okay. So that's how we can go ahead and do that function. Note it uses a loop. Pay attention to how to get to the next number, how n indexes, and how we use a loop to keep getting the next number. Almost there. Question 12. Here's another loop question. An algorithm, this is similar to your homework 7. An algorithm for calculating the cubic root of a number, or the cube root, is described in the table below. Write a function. Here we go. Write a function. X equals third root of p that takes in a number p and calculates the cube root using the algorithm. Okay, so use x equals p as my first number, so n equals 1. And that's this part here. Determine a first guess. Update the guess for the new root. So x2, we'll make this a vector. My first number in x is p. My second number in x is my next guess. So it would be x of 1 times x of 1 cubed plus 2 times p divided by 2 times x of 1 cubed plus p, right? That's my equation. And n equals n plus 1. N equals 2. Okay, so then I'm going to go ahead, that's this piece right here. So now I need to go ahead and update guess for the root. So here's what I repeat over and over and over and over and over again. Repeating step 3 until my error, where that's what it is, or while that error is a big number. So while my difference, so absolute value of x of, oops, there's i's and n's in there. That's okay. I is fine. I and n's, whatever. I have n's though. I should update those to i's. Oh, guys, we're almost done with these questions. Wow, x of my current guess. So x of I minus x of I. I'll do I plus 1. And no, we'll do x of n minus x of n minus 1. I'm just adjusting. So essentially, the I and the I plus 1 indicate 2 successive guesses. So take that, divided by x of n minus 1. While that is greater than 1e to the negative 10, then I'm going to go ahead and keep updating my guess. So x of n. Okay, keeping track of my n values. So x of 3 equals my equation here. X of 2, and x of 2. Then we go n equal n plus 1. So now here, n would be 3. So then it would be 3 and 2. Calculate the difference. And then calculate 4, then go to 4. Okay, I think that works. Let's check it. X equals third root 800. Save it. Spelled third root. No, anyway. Whoops. I don't need all the values. I just need the last one. X equals x of n. There we go. 9.2838. Okay, that works. The other thing I need to do is make sure I terminate the loop early. Okay, so don't forget this last piece. Terminate the loop early if the number of iterations exceeds 500 or 50. There's a couple ways I can do this. I can use a break statement. If n is greater than 50, then I break. This is one way to do it. Let me test my other value. Negative 1.65 e to the negative 8. Yeah, good enough. I just have more digits printed out to the more decimal points. Another way I can do it is I can go ahead and continue. And n is less than 50. That will also do the same thing. There we go. It'll also work and do the same thing. Okay, but I've got this additional piece that says, hey, not only are we doing it based on the relative error, we also are doing it based on the number of iterations, which in this instance is n. Last question. Write a function file. Function A equals double row, triple column. It takes two integers, m and n. Oops. And creates an array of size mn. Okay, so my array is size mn. So I'm going to say a equals zeros, m comma n. Where every element in A will be 2 times the row number plus 3 times the column number. So here, my row is 1, my column is 1, so it's 2 times 1 plus 3 times 1. Here, my row is 2, my column is 3, so it's 2 times 2 plus 3 times 3, or 4 plus 9, which is 13, etc. So essentially, there's a couple ways I can do this. I'm going to use nested loops for I equals 1 to m, for j equals 1 to n, 1 to iterate all the rows, 1 to iterate through all the columns, where a of I comma j. This is the classic programming way to do it. MATLAB has other fancy things because you've got arrays and you've got element by element notation, all that fun stuff. But this is the classic way to do it. So equals 2 times I plus 3 times j. Oops. Nope, don't open Word. Okay. Save my function. Double row, triple column, 3, 4. And I can double check. Okay, that works. Like I said, there are probably other ways to do it. You could probably use it one loop. You want to do one loop. You could say for I equals 1 to m, go over the rows, and then your columns would be 1 to n. And then you could do something like this. All of the elements in row I, all the columns equals 2 times I plus 3 times column. Does that work? Yep, that works. You could also do it across the columns as well. So make this the rows, this the columns, switch these, and then it would be similar. You can also say row equals 1 to m, columns equals 1 to n transposed, and then you could probably do this all in 1 times I plus 3 times 1 times row plus 3 times column. I believe this will also work. Close, very close. I might need to switch them. Will that work? There, that works as well. So you can do some fancy math notation as well with MATLAB, where it does some fancy math. If I look at m equals 3, n equals 4, and I look and see what it's doing, row looks like this. So then 2 times the row is that. Columns looks like this. No, I don't want to do that. I want to do this. So 3 times the columns looks like this. And then if I do this vector here plus this vector here, MATLAB does some fancy stuff that it adds the vector to all the elements. Anyway, that's what it does. So there are some also weird things that MATLAB will allow you to do. But this is the classic way to do it for programming. MATLAB also allows it to do it this way, and then it also wings it and follows its own math patterns as well. Okay, but that is all of our review questions. There were some mistakes. I will go correct those. But you can see that similar problems will be on the practice or on the actual exam. Think about it in terms of length of problems, how much code we're writing. We weren't writing a lot of code for these, but some questions did look at quite a few concepts, like here's indexing, here's element by element notation, concatenation. This one had all the pieces. It had branching, it had element by element calculations, it had displays, it has functions. So you should be thinking about the problems in terms of this length, and think about what kinds of concepts were tested for each question. Okay, so happy studying. I will see you guys at the exam.